Little quiz time. What was the name of the shape that we learned how to graph yesterday? What kind of function do we call a parabola? And we give it a special name. Like last year, we did lines. We called them linear functions, quadratic functions. You want to make sure you understand that word quadratic. Okay, when we graph a parabola, what point on the parabola do we always start with? The vertex. And then from the vertex, how many other points can we get just by moving from the vertex? 4 other points, right? Because we would move 1 across, 1 up to get 2, back to the vertex, 2 across, 4 up, because we're squaring, to get another 2. So we learned the basic graph, y equals x squared, but then we learned what happened if we add or subtract a number at the end. How would you graph this one? We're good? So instead of the vertex, this is how we do it without the table of values. Instead of the vertex being at 0, 0, this tells us we've got to go up 2. So the vertex is going to start here. How do we get the next 4 points? 1 across, 1 up to get 2. Back to the vertex, 2 across, 2 squared, or 4 up. No table of values required. Okay? You just have to remember where x squared starts, and then this tells you where to move the vertex, and therefore every other point. So that's what happens when we have a number at the end of a quadratic function, after the x squared. It moves the parabola up or down, depending on whether it's positive or negative. What happens if we have a number getting added or subtracted inside the parentheses with x and then getting squared? What happens? What do you think might happen? If the number at the end moves it up or down, the number inside being added to subtracted, yeah, I'm just waiting for somebody else. You got it.
You have it because you were in the other class, Peter.
Wow, that was aggressive. Come on, think about it. If the one at the end moves it up or down, the one inside must move it exactly side to side. Okay? So here's what, let's go back to this Desmos thing again. This is, I don't do Desmos activities. I just use the graphing portion. I know that there's strong feelings about Desmos. Okay, here's x squared. Watch what happens when I do another function with parentheses inside with the x. So let's go y equal, whoops, I want to start a new one. Y equals, open parentheses, x, subtract, somebody give me a number. 4. Close, squared. What happened? To the left or right? To the right. So it moved 4 units to the right. So the -4, you may think -4 should move it left, right? Because left is negative. It's actually the opposite. If it's minus, it moves to the right. If it's plus, it moves to the left. So if I said x plus 3 squared, it moves it to the left. Okay? Why does it do that? Because it's in subtraction form. Get back here. Hello. So we don't need this. Notice that the form is in subtraction form. So that means if it's x minus 2, h is 2, which means positive 2 to the right. If it's x plus, isn't x plus 2 the same as x minus negative 2? Don't those mean the same thing? So if I write this as a subtraction, h, this value here, becomes negative 2, which means left. So it makes sense, actually. If it's in subtraction form, this is h. If it's in addition form, h is negative. So this tells us take the original parabola, x squared, and move it which way? And how far? Oh, the confidence is just brimming. Come on, you guys know this. It's the same as x plus 2 is the same as x minus negative 2. So h is negative 2 to the left 2. So I take x squared and move it to the left 2. That's my new vertex. How do I get 2 more points? How much? How much? 1, 1, 1. Back to the vertex, 2, 4 up. Good. Well done. Yeah.
So our thing is x plus 2
Yes.
so x minus 2.
Yes. Because x plus 2 is the same as x minus negative 2. Notice the form that I've given you is in subtraction form. It has to be in subtraction form for you to read h.
So what is x minus 2?
H is 2, it goes to the right. If it's x plus 2, that means h is negative 2, because it's minus negative 2, and it goes to the left. Yeah, good question. Okay, just for a little bit of practice from yesterday, the one that we just graphed, what's the vertex? Sorry? 0, 2? What's the vertex of the one we just graphed? Negative 2. I'm asking for a point, you guys. You're overthinking this like crazy. What point is this? Doesn't a point have 2 numbers? Like, let's overthink this as much as possible. And could you guys push yourself further back in the classroom? Gee. What's the domain? It's always the same for everything. Negative infinity to positive infinity, because it goes to the left forever and the right forever. The range can change, or it can stay the same as x squared. 0 to infinity. Now remember, these next two, the equation of the axis of symmetry and the minimum or maximum value, we get these numbers from the vertex. So the axis of symmetry, and how do I write it properly? I don't just write negative 2. X equals negative 2, because we're writing an equation. And for the minimum value, and it's a minimum because it bottoms out, y equals 0. Once you've got the vertex, you can always get these two just from the vertex. Always. So just like we talked about, if we compare the graphs of the original x squared and x plus 2 squared, we see that they're identical except f of x equals x squared, x plus 2 all squared, shifted 2 units. Learn how to spell. Shifted 2 units left. To summarize, remember, it has to be in the form x minus. So if it's in the form parentheses x minus some number squared, if this is positive, meaning x minus 2 or x minus 3 or x minus 5, so if this is positive, we move h units right. If this is negative, well, minus a negative becomes plus, which means it moves to the left. The vertex will always be whatever the value of h is, comma 0. And the equation of the axis of symmetry is always the x-coordinate of the vertex, so it's x equals h. So let's just practice with one more, graphing it without using a table of values, which we've been doing, which we started right from the get-go. So, yeah, I know, it's such a chore to get up and get that. I know, it's awful. I'm so sorry that happened to you. Okay. Somebody tell me how to graph this. Somebody tell me what to do. Better yet, somebody even come up and graph it. You want to come up and graph it? Yep. Yep, yep. Nice. You got it. Yeah, well done. So instead of starting at 0, 0, we start the vertex 3 to the right because it's minus 3. That means h is 3. Okay? H is not negative 3. H is 3, which tells us to move it to the right. Good. So